this,
Sure.
and it levels off.
Oh.
And you know why that's d&e right there?
Yeah, it has to be a hypothetical.
There's a vertical asymptote on the natural log graph, so that's part of it. Here's the thing though. Whose function would be perfectly modeled by the decrease and the increase with this 1 over x? It turns out that the other part is this. It's a mirror image of natural log. Problem, you're not allowed to plug in what kind of numbers in a natural log? You can't do the natural log of a negative number. Unless.
X is absolute.
You protect this with absolute value bars around the x, then you can get that graph right there. So it turns out that the integration of 1 over x is the natural log of the absolute value of x, so that you get both sides of the first derivative. Sneaky. Very sneaky. Okay? Kids are asking, because we didn't do this last year, so kids in calculus are always asking me, why do we put the absolute value on when you go backwards but not forwards? Okay? This is why. The slope of natural log is simply this formula, but you're only looking on its domain. You're only looking there. But when you go backwards, you have to fit the decrease, increase both, and that's the only way to fit it right there. Okay? With the mirror image natural log. Interesting. So anytime you see 1 over x and you integrate it, I want you to think of natural log of absolute value.
So is that the answer?
Okay? And that's it right there. Yep. Because it had to match this picture right there. Okay? One little twist there at the end. Okay? All right. So that's that one. Now, to wrap this up, let's see when to use natural log, because here's the problem. People get carried away and they use natural log too often.
If it was 1 over x squared.
That's the question. Can we go back and use a natural log?
Oh, I'm sorry.
Okay, I'm glad you asked, because that's right where we're going, right? Okay, now, see question D that we already did. Did we have a something over x squared in question D?
Yeah.
Okay, did we use natural log to integrate that?
No, we did not.
No, we did not. So it turns out that you cannot integrate 1 over x squared and just make it natural log. See, the thing is, students start to think that, oh, if I have 1 over anything, I can just slap a natural log on it and I'm done. Not true. Okay? That first statement is definitely false. Wouldn't you actually just make it x to the negative 2 and just add 1 to the power? Right? Now the second one, however, is the integration of this, does that turn into a natural log? Okay? And this is all brand new, so you're just kind of giving me a hunch right now, okay? Because we don't know yet. Okay? I know, but personally I don't. Okay? Let's see, would that work? You know what this has in common with the one we just did, 1 over x?
It's the same.
It's 1 over x to the
First.
first power. As long as it's x to the first, or in theory it would actually be x to the negative 1, right? But as long as it's x to the first on the bottom, that's the only time you use the natural log. Because that's the time where you get x to the 0 over 0. Okay? So this one is actually true. All right? What about 1 over e to the x?
No.
Could you just slap a natural log on it and say, oh, there's the integration? Nope, and I'll tell you why this is absolutely preposterous. Do you remember what the natural log of e to the x is?
1.
Don't you cancel natural log of e and just get x? Okay.
It's e to the base, that's all.
What is x? Y equals x when you graph it?
It's
It's a line.
Cuts the first of the pure part.
Yeah. Y equals x is just a line. It's x plus c, I guess. So it could be shifted somewhere. Okay? But you know what it is? Sure, it's just a line. Now, the derivative or slope of a line is measured by an exponential function. Yeah, right, sure. Okay? The derivative of a line is a constant because the slope is constant. There's no way it can be exponential. That's preposterous, right? Not even close. That's false. Okay? Now look over here. The integration of 1 over cosine squared. Well, Mr. Wade taught us that 1 over anything just turns out natural log. No, I did not. No. 1 over x to the first. Okay? Matter of fact, you can't do that. That's false. And let me refer to something we did prior this year. You know what the integration of 1 over cosine squared is if you think about it. Done before.
Cosine.
Oh, yeah.
Oh, it is?
It's cosecant. Secant. Tangent.
Tangent. Children. You're right. Very
Well-
impressed. Okay?
I just because I was going through all of
What's
them.
that?
But you were thinking secant squared, right? You were thinking that.
Yeah, I
Okay?
had
Plus
to
that.
split
Plus
it.
then, of course, yes. That was a very different stuff. That's a thing right there.
That's the only one that we did.
Oh, well, special. All right? So, 1 over cosine squared is the same thing in math as we also call this what? Secant
Yeah,
squared.
that's what I thought.
Right. But whose derivative gave us secant squared back in the first semester? The derivative of tangent is secant squared. So the integration of secant squared is tangent. And actually, we're going to learn that tomorrow officially. So there's no way you can just put a natural log on it. It's actually something totally different. Okay, the last two. Could you integrate 1 over x cubed plus x squared plus 1 and just put a natural log on it? There's a problem. What's the highest power? Third degree? Can't do it. Don't just throw around these natural logs willy-nilly. Right? Oh, I'll just use it all the time. What about the last one?
Yes, that's the first.
It's x to the first, so you can go straight to natural log, and it actually does it.
Just have an empty circle.
Okay, yeah, what's in there? Okay, check. All right, we got it.
Except,
You can now start to become integration masters.
oh no.
Solve